Now you're afraid to buy all those fresh fruits because of the cyclosporiasis. You know? Yeah, they have it. Yeah. Native to, I haven't heard any from the Tampa area, but within the coastal areas.
All right. Happy Sabbath, everybody. Today is, let's see, today is
Echoing again, Jackie.
July 18, 2026. Can you just turn it off?
Yeah, turn it off.
Yeah. Today is July 18, 2026. And I just want to do maybe a short series. We'll see how long it'll go. About what we have now described as the microbiome. Microbiome. So what is the microbiome? Right. The microbiome is actually all the germs, not only germs, but funguses, Firmicutes, viruses in your gut that lives with you, right? Some are good, some are not so good, right? But the microbiome is actually a balance of all those living organisms in your gut. Yeah. Now we always think about germs and viruses like kind of bad. We always think of it as bad. But actually, germs and viruses in the gut, funguses, actually are needed. It's actually needed, right? Yeah. But as long as it's in a balance, right? So the microbiome is basically a balance of all the living organisms in your gut. And they say that it used to be said that there's actually more organisms with different chromosomes in your intestines than there are human cells. But now they say it's really about the same. But there's so many more different. We have one set of chromosomes, right? All our cells have one set of chromosomes. But all the chromosomes in the intestines are so many different kinds, right? So it's just incredible, the knowledge that we have gained recently. And, you know, why is it so important for us, right? Okay. And to start this, we have to start in obviously we start in Genesis, right? We start in Genesis. All right. Right? God created all the food that animals and humans need to eat on the third day, even before the animals and the humans were created on the fourth, fifth, and sixth day. So God prepared their food for them before they were even created. And the food for the animals were the grasses, right? The grasses and the vegetables, right? But for the humans, it was nuts, grains, and fruits, right? And that was designed in the Garden of Eden, right?
You know what is really surprising for me? Water was there and everything before land appears.
Yeah, obviously, yeah. And light. Without light, there's nothing will grow, right? And has to be water. Water and light had to come first, right? Mm-hmm. Right, there you go. Yeah.
That's what he said before God created the water. You know? Yeah.
Mm-hmm. Yeah. So, right? And we obviously know that for the animals it was grass, and nuts, grains, fruits were for humans, right? But all the fruit was good, except one fruit was a test for Adam and Eve, right? And God said, thou shalt not eat of that fruit. But Satan deceived Eve, right? And said, because of Yeah, what
It's
kind of fruit?
definitely not durian.
It's not durian, yeah, because it had to look good. It had to look good, and it actually must. Eve said, "Okay, not only does it look good, but it must taste good, right?"
Looks good, tastes good, smells good.
Yeah, and Eve was deceived and fell into sin. Right? So this is what their food was in the Garden of Eden: fruits, nuts, vegetables, fruits, nuts, and grains and seeds. Right? But then they fell into sin, and because of sin, that's an emergency situation right there. Right? You have to now die. But God said, "Okay, before you have to die, I'm going to come to your rescue, and I will give you a solution." Right? You have to die, but then my solution is that I'm going to die for you. Right? So that's the solution for death. That Jesus, as the Lamb of God, will die. Right? But then he says, because you have sinned, you women have to suffer. And you men have to suffer also. And the solution for all that suffering is what? The herb of the field. What I gave to the animals. So, can you imagine that? Suffering, which causes diseases, the solution of it is actually vegetables. Right? Because that is, God prepared vegetables and herb of the field for the impending sufferings that they have to suffer. God actually always prepares something for you before it happens, right? Something he prepares the vegetables for you because of your impending diseases that you're gonna get. All right? Okay. Yeah. So, animals eat the grass, right, and the herb of the field. And then God said also, when you go to Deuteronomy, what kind of animals are considered clean animals that you can, the one that the hoof is parted and chews the cud. What does it mean to chew the cud? They regurgitate, they eat the food, right? They eat the grass, right? They eat grass, and they regurgitate it, and they continue to chew, right? So how is that grass actually broken down to what they need? Because, right, continue. What breaks it down? Yeah, what's in the enzymes though? Germs.
Yes.
It's the microbiome of the cows. So when you think about it, God created the microbiome in the cows.
Did you see
right?
the University of Wisconsin? They have a literal cow, a living cow, that they remove the skin and it shows the stomach of the cow. And the cow just is alive, and they could see that. They replace it with, I don't know how they replace that, probably, the plastic thing. And so when the cow feeds it, and then they collect all the samples of whatever inside the cow produces, and that's how they study the microbiome of the cow.
Yeah. So the cow gets all the fat, all the protein, all the carbohydrates, all the vitamins from what? From grass, from plants, right? Everything that the cow gets, and the cow obviously can get pretty big, right? Because and one of the fats is actually called linoleic acid, right? It's an unsaturated fat, right? It's unsaturated fat. Now this is broken down by the microbiome, right, to become short-chain fatty acids. Okay, short-chain fatty acids is very important, right? Because it's the food of the intestines. The muscle uses sugar, but short-chain fatty acid is the food for the intestines. Okay, that's very important. That's good, right? But what else does it make? Vaccinic acid. Okay, vaccinic acid. You look at vaca. What's vaca? A cow. Okay, it's in cow. Bacinic acid is in cow. Okay, what kind of acid is that? It's trans fat. Okay, is trans fat good? Oh no, that's bad. Trans fat is bad. Why? It really causes your heart disease. Trans fats causes plaques, right? It's proven. Trans fats. Trans fats is actually now banned from food, but it's actually natural in the cow. All right, it's broken down. What else? Now you have saturated fat, stearic acid. Where's the steer? It's from a steer. It's from cows, right? Stearic acid, right? Yeah, bacinic acid, trans fat, and now saturated fat. Compared to unsaturated fat, is saturated fat good?
No.
No, it's bad. This is bad for you. Okay, so why did God say, okay, you can eat a cow when it has trans fats and saturated fats?
Also,
you're suffering also because it's you have to compare it. It's better than eating a pig.
That's true.
Why? Why is eating a cow better than eating a pig?
Because their fat is worse. The pig's fat is worse than the cow's.
Oh, there's
the much dirtier.
Yeah.
Oh.
Plus they don't.
They are so much dirty and so much infections, right? Trichinosis. Wow. Echinococcus, right? What about like the seafood that is unclean?
They're bottom feeders.
Bottom feeders. All kinds of diseases, right? Right. Yeah. What about bats? So many.
There are different bats though. The finance.
Oh yeah, but they are.
But they're not.
They're a breeding ground for like 100 different viruses.
That's right. They're not for the consumption.
Right. So these unclean foods are so much worse for you because they have all the diseases as well, right? As compared to the clean foods. All right. Okay. So
God created them for a reason.
Yeah.
Garbage collector.
Right. Yeah. So let's see. We study the microbiome. Who's the first one? We studied this back in biology. The first person that figured out germs, right? Figured out living animals. He called it small animals, but they're actually microscopic, right? Microscopic living things. Anthony van Leeuwenhoek, right? He's the Dutch, and this is his first microscope, and he look at all these little protozoa and and he called it Dirchus. Dirchus is tiny animals, animalcules, and then these germs. Now we look at a plate. Oh, look at that. Oh, these germs. And then we classify that. We look at under microscope. Some look kind of, when we stain them, look kind of blue. There's gram positives. The one that look kind of red is gram negative. So that's a classification, right? And this is what it looks like under the real electron microscope. All those germs. What we can grow is only very small compared to how many there are. We just can't grow them, right? So we classify them, the one gram positives, gram negatives, and then we can actually make them move in an electrical field, and then we can classify them that way. But now all the chromosomes, now we have testing, like all the chromosomes, we can actually put it in a machine and look at all the different chromosomes. Thousands of germs, different germs in our gut, thousands, right? All these germs, and then they start classifying it, right? Some of these, the more of the gram positives are the Firmicutes. More of the gram negatives are called Bacteroidetes, right? And they found out, people who are diabetic tend to have more Firmicutes than Bacteroidetes. They say, oh, there is a correlation, you know. People who have certain diseases have more of these type of germs. So they say, wow, this is incredible. These germs must have something to do with the diseases, right? So all these germs, like, for example, do you think the germs on your skin are all bad? No, they're actually good. Why? To convert the sun rays to vitamin D, you need germs, right? Yeah.
The germs for everything.
Right. Yeah. For your intestines, your gut, to have a good pH for digestion, you need germs, right? Yeah.
No, germaphobe, not good.
For women, when they give birth, they have to have the vaginal pH has to be a certain pH,
Yes.
for it to be healthy, so that when the baby passes through, the baby remains healthy.
Yeah.
And you need germs to keep that pH, So all germs are not bad. We need germs. God created germs, Yeah. So, and when we were born, initially in the womb, there's no germs. But when we are born, then we start developing the germs that we get. The first is, this is kind of amazing. They look at germs of the babies who was born by cesarean sections. Those that were born by cesarean section do not get the mother's vaginal germs, right? They get skin germs. They pass through the skin that is open, and they get touched by the nurses. So the germs that they get is skin germs. The gut germ that they get is skin germs. As compared to the babies who are born naturally, their gut germs is more of the vaginal mothers, And then these babies get sterile formula as compared to the ones who get mother's milk, which is full of germs.
Yeah.
But these germs are good.
Yeah.
So they get every baby starts off differently, right? Depending what the mother has, depending on the antibiotics, depending on the food that they get, depending on their milk that they get, how they were born. So everybody is different, pretty amazing, right? Yeah. Okay. So, what does this mean, right? So they look at the twins, right? They look at twins, and they found out that though the twin that eats more fiber, right, their germs make more butyrate. Now, butyrate is actually very important. Butyrate is the food for your intestines. For your intestines to live healthy, it needs butyrate. And where does butyrate come from? Fiber, right? That's the biggest thing, right? If you're in it, you need fiber, right? For your germs, for your gut to be healthy, right? For your gut to change every 7 days, it needs food, right? It needs food, right? So your diet, determines, what your germs are in your gut, all right? Okay. All right. I'm going through quickly about these. I don't want to belabor the point too much. We have a lot to show, right? And how fast does it change? Within a few weeks. So if you move to a different community, all right, it's not where you live that changes your gut, but the type of food that you eat. Like, for example, a person who used to live in the community now goes into the nursing home. Within a few weeks to about a month, now the microbiome changes to the kind of microbiome that is common in that nursing home, right? Yeah. And not all the germs change. A small amount of the germs change. Some of the germs there remain stable. The ones that change, a small amount, So everybody's different, right? But eventually it changes depending on the food. All right. Okay. All right. So when they looked at it, now they use AI now. It's pretty amazing. They use AI. And they look at, all right, okay, they look at the microbiome in a person's gut, and now they can predict what kind of reaction they have to diseases, right? They look at the microbiome and says, okay, you're going to be more susceptible to diabetes, or you're going to be more susceptible to Alzheimer's, right? Yeah, based on the microbiome. It's pretty amazing. Yeah. So, right, the food in the Garden of Eden was, plant-based, right? It was nuts, grains, fruits, and then after sin, it was vegetables that was added. All right, okay. You know why? Because even with the impending diseases that was going to come, God actually did not say, okay, you can eat animals yet, right? He says, no, you eat vegetables. When was the animal food actually introduced and said was okay? Is it not after the flood? Before the flood, right? Because as the animals were walking in, right, God said, okay, the clean animals, there'll be 7 of them. And the unclean, there'll be 2, right? Why? Why 7?
Still need for more.
Yeah, you gotta eat those. You gotta eat those clean animals. And what else too? You have to sacrifice, right? Your sacrifices have to be clean animals, and you gotta eat them. That's why you gotta have more of them. Right? So and that was also because of an impending catastrophe, a global flood, right? So God prepared the animals to be eaten before the flood, right? Yeah. So
you always have provisions.
Right. The provisions are already made, set for you. All right. Okay. It was because of a flood, right? But then you see, then you see in the sanctuary service, right, for the Hebrews, the sanctuary service, the priest will have to eat the meat, and then the meat is also given, right? And the Passover lamb has to be eaten by the Hebrews. Why? Because they had forgotten who their Savior was in Egypt, right? For 215 years, they were slaves. They forgot the Sabbath. They forgot who their Savior was, and they had to be taught. And they had to be taught literally, right? Because the priest is a type of Jesus. And Jesus bears the iniquity of sin in his own flesh, right? So that the priest has to eat the meat, right? And then people had to eat that meat also, which means that they actually had to take in Jesus. They had to learn about Jesus, and they have to incorporate what Jesus means to them in their life. So it was a literal, the eating of meat was actually designed for them to learn about the plan of salvation, right? Yeah. So there was, that was why meat eating was still allowed, right? Until Jesus came, right? And there's no longer any need for sacrificial meat eating, right? Okay. All right. Now we go to the time of Jacob and Esau. Now this is the first time that in the Bible there's a comparison between the food of Esau, which is meat, and the food of Jacob, which is lentil and bread. All right. Okay, this lentil and bread. Now, what is the when you look at this, what is the lesson here from the Bible? Yeah. Why did Esau decide that he wants to sell his birthright for red lentils? Because he cannot overcome his his lust, right? Yeah, because he eats a lot of meat, and then because of that, he cannot overcome his lust, right? And he's ready to sell it because he knows that eating lentils will make him last longer he was so hungry that he knew eating lentils would satisfy him better. And, and it's actually proven that when you eat high fiber diet like lentils, you can last a lot longer, right? Yeah. Yeah, for your next meal, right? Yeah. And then that's a comparison. The first comparison in the Bible of eating meat versus eating plant foods, right? And then another one that's so famous, right? In the book of Daniel, right? It's the comparison of eating the king's meat and wine versus eating pulse and water, right? And then it says right there, though Daniel knew that eating meat will defile him. Now, this is actually very interesting because in the Bible it says it's not what you eat that defiles you. It's what is inside of you that defiles you. Right? Right. It's what defiles you it's what is inside you. Because what? When you eat a food that you have a lust for, what defiles you is your lust. It's not the meat. It's actually the lust, right? The eating of that food that actually is not good for you, it's actually a manifestation of the lust in your flesh. And that's what defiles you, right? So what's the difference between Nebuchadnezzar's meat and the pulse that Daniel ate? What is the real big difference, from a scientific basis? Why is the pulse better? There you go. It is the biggest difference is the fiber. Both have protein, right? Well, there's no carbohydrates really in meat, but the type of carbohydrate that's really good is the fiber, right? So we're just gonna go really quick into fiber, right? Right, and carbohydrates. So there's type of simple sugars, right? The simple sugars are like table sugar. It's basically glucose and fructose, and that's called sucrose, right? Even the milk is now, is milk actually a processed sugar? Is the lactose in milk, is that a processed sugar?
No. That's from, unless the one that you buy from them is a production from them, but the natural milk, like mother's milk and cow's milk, they're natural sugar.
The thing now I want you to think about this. Where did the mom and the cow get its sugar? So actually the cow processed plants,
I think
right?
Processed
yeah. So actually milk is a processed sugar. The milk, the sugar in milk is actually processed.
Compared to sugar cane.
Right, because now sugar cane obviously processed, right? And the grass is processed by the cow to make lactose, right? But this is processed. And when it's processed, it goes into your bloodstream. It spikes your sugar really quick, right? Because it does not have to be processed anymore. It goes into your bloodstream. Boom, your blood sugar goes up quickly, right? Right. Compare that to the complex carbohydrates, right? Complex carbohydrate is glucose. It's all glucose, but the glucose is in chains, and this is much more difficult to digest, right? It takes longer to digest this. So when it does become digested, your sugar does not spike, but it goes up slowly, and it lasts longer in your system, right? So your sugar does not spike. Now that's a good thing, right? Especially if you're considering about diabetes, right? You don't want your sugar spiking, right? So complex carbohydrates, much more difficult to spike your sugar, last longer, right? Now, the names of amylose and starch. That's basically starch, right? Now compare that to fiber. Fiber is carbohydrates. The difference is there's insoluble and soluble. Now, fiber is also like wood, cellulose. We cannot digest this. Termites can, but we can't. Right? Right. They can't. So it sweeps. It goes into your stomach and it sweeps. It's like a broom, right? It's like a broom. It's good for, and it absorbs. It also absorbs some of the things that you don't need, right? Yeah. And now the soluble one is like the beta-glucan. This is like beta-glucan. This is soluble, right? It's soluble. It's not like this. We can digest this. But who digests it for us? We cannot digest it. It's the germs that digest this. Germs can digest beta-glucan, right? Beta-glucan, right? And turns it, all right, okay? And these fibers are only found in plant foods, all right? It's only found in plant foods. Animals and humans do not have fiber. Fiber only comes from plants, right? So, it's very important that we get our fiber, right? It's very important, and the only place we can get it is from plants. Right. Okay, right. The gut microbiome and role of obesity and insulin. Right. Yeah. So, when you change your diet to eating more fiber, within 3 days, you can start seeing a change in the microbiome, right? Yeah. Your response, your insulin resistance and your systemic inflammatory markers can right away be checked, changing to a more high, within 3 days, right? How many days did it take for Melzar to notice that Daniel had a more fair complexion? 10 days, right? 10 days. Here, within 3 days, you can actually tell that when you test, your insulin resistance gets better and your inflammation in your body gets better when you change to a more high fiber diet. All right. So what does the microbiome do with your fiber? All right. Wow, this is complicated, so many things, but I just got to summarize this, right? The fiber is broken down by the microbiome, right, to become the energy source, right? The energy for the cells of the intestines. Remember, it does not use glucose. It uses butyrate. Butyrate comes from fiber, right? So for your intestines to be healthy, it needs to be fed butyrate that comes from fiber, right? And the intestines changes every 7 days. You make new cells every 7 days, right? So, that's very important, Yeah. Because for your cells to change, the dead cells has to be recycled. And how does the dead cells get recycled? By your immunity. Your immunity is actually one that's killing off the dead cells, right? Your dead cells just doesn't die. It's actually your immunity that's recycling. Right? Now, it's the immunity that keeps the cells from being so loose. And, the cells have to be tight with each other. Because otherwise, stuff inside the intestines will leak. You don't want a leaky gut, right? You heard of leaky gut?
Yeah.
Oh, the leaky gut is not good because the things that inside your gut can leak into your bloodstream, that's not good. You need tight junctions in your intestines. And it's the immunity that keeps those tight junctions. The cells need to have its food, which comes from fiber, and the immunity. The butyrate actually, stimulates your immune cells to keep your gut healthy. And you have a mucus layer, right? The mucus layer is kind of a barrier, so germs don't just go easily in. And those the mucus is made, with butyrate, right? So, all of that, this is very important. This is why the microbiome and your food that you feed your microbiome, which is the best food, is actually fiber, right? Yeah. And what else? Remember GLP-1? Mm-hmm. Man, GLP-1 is so hot these days. Everybody wants their GLP-1.
That's why all those actors are getting so skinny.
Yeah.
Yeah.
But where is GLP-1 made? In your gut, broken down by fiber into butyrate, and butyrate is the precursor for GLP-1. So you want natural GLP-1, you get it from fiber. So people who don't want to eat their fiber, they inject GLP-1. They're rather, I don't want to eat fiber. Who wants to eat like a cow? I want to eat the cow and get my GLP-1. Yeah, costs so much. Yeah. These days, it's starting to be covered by insurance, right?
Yeah.
Yeah. Right. Yeah, it's getting cheaper.
It is.
Yeah, because the Sanofi has made so much money, they now has covered their their research costs.
Very true.
All right. Yeah. So now all is profit now. And then bile acids. The gut bacteria breaks down your bile acids. Now, I have what here? Okay. Bile acids is actually made from cholesterol, right?
Yeah.
And it's broken down by the intestine germs, so that the bile acid does not get reabsorbed. So your cholesterol level goes down because the gut bacteria breaks down those bile acids. And there's bile acids, when it's broken down, the metabolites, what is broken down, it actually increases your thyroid function and increases your muscles. That increases your metabolism, right? Breaking down the bile acids increases your metabolism. Breaks down your cholesterol, increases your metabolism. So here's the fiber that comes from plants, right? And the protein that comes from plants. It actually, the amino acids are combined together and broken down by the microbiome. Now we know microbiome, right? Right? And it becomes short chain fatty acids, some acetate propionate, but the most important one is butyrate right there. Yeah, it's a 4-carbon chain. All right, butyrate there is important because, right? Oh, sorry. Butyrate is the food for your intestinal. There are those cells, right?
Yeah.
It's only one cell separating the intestine. Your blood from the germs inside your intestine. Only one cell.
It's thin.
It's very thin, right? It has to be kept healthy. Yeah, your immunity is only one cell thick. Can you imagine that? You have to make sure that it stays healthy, right? And to feed all those cells, you need butyrate, right? Butyrate, it actually feeds those cells, right? Yeah. All right. All right. Butyrate also makes GLP-1. Okay. Oh, butyrate also affects your immunity, improves your immunity, so keeps the cells healthy, keeps the cell turnover, and keeps these junctions tight, right? That's the role of your immunity cells, right? And also produces GLP-1. GLP-1 goes to your stomach, makes your stomach digest slower, right? So your sugar doesn't spike. Goes to your pancreas, make your pancreas secrete more insulin. Goes to your liver so that your liver doesn't push out the sugar that quickly. And what importantly, also it goes to your brain, makes you less hungry, right? This is GLP-1. This is why it's such a good drug to make, right? All right. Yeah, it's a really good, all right? It's really good. Okay. But also cholesterol, right? The cholesterol in your body, right? is turned into bile acids, right? These bile acids is broken down into secondary bile acids, right? And then it stimulates TGR5. Oh my goodness, what's that? Takeda G protein receptor 5. My goodness. Yeah. But anyway, this increases GLP-1. Also, this actually goes to your thyroid, to your muscles, to increase your metabolism. And because you keep using up the cholesterol in your body, now your cholesterol goes down and your metabolism goes down higher. All this from your microbiome, right? So this is why we study this more and more, and we realize how important the intestinal germs are, right? Okay. All right. This is where the National Geographic.
Fred.
Because according to popular culture, what did Fred Flintstone eat? Or paleo, in the paleo, what is the paleo diet? What did right? Look at all these pictures.
Yeah.
They must have been eating meat all the time. All those cavemen, they were eating meat, right? That's what popular culture said.
Yes.
But then they did a study called coprolite. Coprolite is actually the study of fossilized feces, human feces. So they find the fossils of the feces, right? And they studied it. And they checked, what did these cavemen eat? What did they eat? Mostly plants. They actually ate mostly plants. Can you imagine that? So all these movies and about the cavemen eating meat, they actually, because if they had to eat meat, they had to chase a dinosaur down, and that's much more difficult than collecting, right?
Or a rhino.
Yeah, than just gathering food.
You send out the woman to go get it.
Yeah, there you go. Then you go chase a dinosaur. Oh, forget that. Yeah. Actually, the cavemen actually ate more plants than the standard American diet. Yeah, so much more. Right? Yeah, it's pretty amazing. Okay. Yeah, here is the Paleolithic, like 110 grams of fiber. Compared to the current U.S. diet, only 12 grams. Right. It's pretty bad. Yeah. Standard American diet at 12. In those days, they probably ate like 8 to 10 times as much fiber. The Paleolithic, those cavemen ate more. Right? Okay. So, the first doctor in the West that realized, when he was a missionary in Africa, his name is Dr. Dennis Burkitt, so famous, because Dennis Burkitt is the one that found out that there's a certain type of cancer that is caused by infections. It's called Burkitt's lymphoma. It's caused by a virus. Then he goes, oh, that's kind of amazing, because one of the most common cancers in Europe is caused by their diet, which is colon cancer. And they say, how come there's so much colon cancer in Africa, in Europe compared to Africa, right? Colon cancer. And they say, how come there's not much diverticulitis, diverticular disease, irritable bowel syndrome, appendicitis, varicose veins, hemorrhoids, diabetes, obesity, or atherosclerosis? All this is so little in Africa compared to Europe. And he says it's got to be the fiber. So he's the father of fiber hypothesis. And he found out, that the best amount is between 25 for women and 38 grams for men, right? And most Americans eat only 12 grams. Only 5% of the United States population eat enough fiber. That's actually for Yeah.
They got the
But we
fiber
can
in the
actually
burger.
eat 50 to 100. Yeah.
Yeah.
Right? So, the standard American diet is really lacking
Sad.
in fiber. Really lacking fiber.
It's a sad
So,
diet.
but the issue is that all the time people are said, where are you getting your protein?
Yeah.
The standard American diet is not low in protein.
I have one doctor ask me that. So I said, where do you think the cows get their protein?
See, the thing is that the American diet is not low in protein. It is really low in fiber. And this is why the European diseases are all these diseases. All these diseases are the diseases of lack of fiber, right? As compared to when you compare it with the people in Africa, right? And, they found out all the Western lifestyle inflammatory diseases is a result of a lack of fiber, and because it causes chronic inflammation in your body, right? The low fiber diet causes chronic inflammation in your body, right? And then they found out, okay, here you go. What about the carbohydrate quality of the fiber? Eat more fiber, right? All-cause mortality goes down. More fiber, all-cause mortality goes down. Coronary heart disease goes down, right? Diabetes goes down. Colorectal cancer goes down. It's all correlates, right, with fiber, right? Okay, right. Now they actually look at reduction, more fiber, right? More fiber, lower body weight, lower cholesterol, lower blood pressure, lower coronary disease, mortality and incidence of diabetes. Reduction in all-cause mortality, total cancer death, cardiovascular, stroke incidence, colorectal cancer, esophageal cancer. And the best is to get between 25 to 29 grams a day, right? But unfortunately, the population usually eats less than 20 grams a day. 95% of Americans eat less than 20 grams, right? Yeah. So then when we go to diabetes, right? Yeah. The first description of diabetes is actually even when the time of Pharaoh, right? They noticed, the pharaohs noticed, well, the wise men of the Egypt, they wrote down that when they see these people, they pee a lot, they urinate a lot because diabetic, the sugar level in their urine is high. And that's why they urinate a lot. So they said, they eliminate urine, which is too plentiful. Diabetes was already described way back in 1500 BC. Actually, when you look at that, that's the time of Moses. 1500 BC is actually the time of Moses. And from that time on until now, is diabetes decreasing with all the good healthcare that we have? No, it's as we get older, diabetes is rising, right? So even when we're in our 50s, we think, oh, we're not going to get diabetes anymore. Oh, you still can get it. Yeah. Only after you start dying off, these numbers start going down, right? Right. And it keeps going up, All the new medicines, all the good healthcare that we have, the diabetes in the world does not go down. It keeps going up, right? The number one prevalence is in China, India, right? United States, number 3, right? And well, I look at Indonesia, right? Number 7, right?
Sad thing is, when they started doing the diet the Western way, then all those diseases came in. What was that? Just start from the basic. But then you look at the country, they started having McDonald's.
That's right.
Wendy's,
Right.
How do you feed so many people? It becomes a dilemma.
Yeah.
Yeah.
Right? So,
Billion of people.
yeah. How do you feed them all?
And then when you see what happens, they're projected. When you see the numbers,
Incidence of diseases.
right, the projected numbers, none of them go down. It continues to go up, right? It continues to go up, right? All the numbers. Yeah, Philippines is not here.
I think in the 15th.
Yeah, but the population of the Philippines compared to Indonesia is still kind of low. Indonesia is a lot of people, right?
China's close to what? Are you close to 2 billion?
Yeah, he has billions of people. Yeah, but China's still number
India.
one.
India is one. Yeah, India was.
Yeah. Anyway, right? So they go, what is the cause for diabetes? So this is in 1927. They go, what is the cause of diabetes? They know it is diabetes mellitus type 2. What is the cause for diabetes mellitus type 2? And it's insulin resistance. Your body, your muscles are resistant to insulin. Your muscles need to have glucose. But glucose is not getting in there because what actually allows glucose to get in is insulin. And your glucose is not getting in there and stays in your bloodstream, right? It stays in your bloodstream. It's not going into your muscle, right? And that's why you're insulin resistant, right? So the definition is actually insulin resistance. So they go, okay, let's check what causes you to become insulin resistant. Now when I was in medical school, it's all about sugar. Too much sugar. All right, carbohydrates, carbs. All right, too much sugar. Right. So then in 1927 they said, okay, let's do a glucose tolerance test. Right. So they give a bunch of glucose, right, and see how well you can tolerate that glucose. People who can tolerate that glucose, their glucose after getting a big bolus of sugar, their sugar does not rise that much. So people who cannot tolerate it that much, their sugar rises, right? Right. So let's do a glucose tolerance test. Yeah, and they compare two different groups of people. One gets a high-fat diet for 2 days, right? For 2 days, a high-fat diet. All they eat is a high-fat diet, and then they get a glucose tolerance test. They just give a sugar water, right? Right? They give sugar water. And then they check the sugar at fasting, 30 minutes, 60 minutes, and 120 minutes in 2 hours, right? And then they compare it to another group of the same young men. All they ate was carbohydrates for 2 days. And they gave them sugar water, right? And they check, right? Which one will spike higher, right? The one getting all carbs or the ones getting all fat? Yeah. Right? So there's one here. The one one goes up. This one is glucose intolerant. Right? And this one, this one is not glucose tolerant because they can handle the sugar. Right? In other words, their insulin become resistant here. Yeah. Here, their insulin is not resistant. Right? Which diet is the one that causes it? I'll say, wait a minute. Okay, let's switch them. Okay, let's switch these people out. And they tested it again. It's the same thing. Right? In other words, you do the crossover and it's still the same. Right? Okay. So which diet? Which one that causes the glucose to go high? Which one causes the insulin resistance? The fat diet. Fat actually causes insulin resistance. It's not the sugar that causes insulin resistance. So people were saying, this is 1927, but they could not figure it out. They go, what? This doesn't make sense. They cannot figure that. Why is it that? So they go, okay, all right, maybe we don't know. Why is it fat that causes people to become insulin resistant? All right? Until until in 1999, they get an NMR spectroscopy. Now they can actually look into the muscle, right? Because then the muscle is where your glucose is needed, right? And they look into the muscle, and they look into the muscle, and they go, oh, there's a bunch of fat in the muscle cells. Intramyocyte lipids. In the muscle, there's accumulation of fat in the muscles, right? And that, when you have cells, the muscle cells full of lipids, the glucose cannot get in now, right? Because it's kind of thinking, well, there's already a lot of calories in there. I don't need to get in there anyway. But then, you can think of it that way. But the glucose does not get into the cells because it's already full of fat, right? And so that's why it stays out in the bloodstream. That's why your blood sugar remains high. Yeah. And the insulin is not letting it get in. That's why you're insulin resistant, right? Because of the fat in the cells. They go, oh, okay. It's only 70 years later. This is after I graduated medical school. I did not learn this in medical school, right? And you know what? A lot of doctors don't even know this. A lot of doctors, even now, will say it's your carbs. It's your carbs. In 1927, they proved it's not your carbs. Sure, the sugar will go up because you eat more sugar, but it's not the cause for your insulin resistance, right? It's actually the fat inside your muscle cells, right? Yeah. Okay.
And then you have to think also, even the diabetic, because diabetes is reversible.
Right.
It's with the sugar.
Right.
So
This
you're
is
right. They might as well go to a GI doctor.
it's okay. Now this is what they look at all these. Oh, all these. This is the muscle. All this fat now accumulating, right, in the mitochondria of the cells of the muscles, right? The fat in the muscles, right? Okay. Now they go, wait a minute. How did it get there? How did these fat cells get in there? And they found out that it was valine. Valine is a essential amino acid. It's essential. We have to get it from our food. It's essential branch chain. Look at it. It's branched. It goes like this, and then it branches up there. It's a branch amino acid. And branch chain amino acid called valine is broken down to 3-hydroxy or something, 3-HIB, butyrate. Anyway, 3-HIB. 3-HIB is what lets the muscle accumulate the fat. It allows the fat to get in, right? By valine that is broken down to 3-HIB. 3-HIB allows fat to get in, right? And what is valine? It's an essential amino acid, right? What are the foods that is high in valine? Animal protein. Now, plant protein is low in valine, right? But animal protein is high in valine. So then people say, okay, people always ask me, is the white of the egg okay? Well, the white of the egg is probably better than the yellow of the egg. But the problem is that the white of the egg contains what? High amount of valine. Right. Yeah. So this is so valine is broken to the 3-HIB and allows fat to get in, right? And the glucose gets stuck outside in the blood vessels, right? And your glucose remains high. Now, this is what I just learned in the last couple of weeks, right? I had to.
Medical school.
Oh yeah, I'm studying all the time.
There's a lot really now.
Oh yeah. You guys get 2 hours of credit for biology here. All right. what the 3-HIB, how does valine get broken down to 3-HIB? The microbiome. Your microbiome, breaks it down. What happens? When you have enough fiber, right, that microbiome will break down your fiber into butyrate. But if you don't have enough fiber, now the microbiome breaks down valine, protein. It now starts using protein. It starts breaking down protein. And when it starts breaking down protein, the microbiome changes it into the 3-HIB. And that actually allows fat to get in, right? So it's the microbiome that starts breaking down the protein, right? This is pretty amazing, Microbiome is so important, right? So you have to have a good microbiome, and you have to feed it what it needs. It's actually fiber, right? Okay. All right. So this is the mechanism. And, this is down below those cells, the blood sugar is up there, right? And there's the insulin receptor, right? Here's the insulin receptor, right? And that's insulin, right? Insulin receptor is supposed to attach right there, right? And allow glucose to enter, right? Right? This is the door, actually. The door is actually hidden for the glucose to enter. This is the cell inside here. This is the blood, right up here, right? There's the door. The door is actually hidden, right? And the mechanism for this door is open is actually kind of complicated. It's like the insulin will attach to the receptor, and now you got 1, 2, 3, 4, 5, 6, 7. A 7-step procedure for now the door to open up. So now the glucose can come in, right? Now you can make this open up also by exercising. So exercising will make the glucose go inside as well, right? But this is a very complicated mechanism right here to open up for the sugar to come in, right? But the key is insulin. The door is this, and the lock is the insulin receptor, right? So this is the key, the lock, and the door, right? You need all to work, right? All right. Yeah, you got that's right. Okay. Yeah. We have 3 nurses here, so they all you guys know this. You see this all the time. All right. So what is diabetes mellitus type 1? Type 1 is when your pancreas doesn't work anymore, right? Your pancreas doesn't work, and then so what happens? You have no insulin, right? The pancreas doesn't work. It's supposed to make you insulin. You have no insulin, right? You have no insulin. When you have no insulin, all the blood sugar in your blood cannot get in. Unless all you do is exercise. Exercise forces it. But then you can't, yeah, right? You need insulin for your glucose to get in. It just stays out there, right? So what do you have to do? You have to inject insulin. You inject insulin, all right? So now, this is diabetes mellitus type 2, right? Diabetes mellitus type 2 is when you have the 3-HIB, right? 3-HIB comes from what? Valine, amino acid. The amino acid is broken down by the microbiome because you don't have enough fiber, right? When you don't have enough fiber, valine is broken to 3-HIB, and this is fat. Fat gets inside, right? Now the fat goes inside, right? Your pancreas still makes insulin, right? Still makes insulin. But the problem is that, what kind of fat is it that goes in? It's saturated fat. Saturated fat is the type of fat that gets into your cells, right? And saturated fat, like the palmitic acid fat, is found more in animal fat. So the animal fat plus the animal protein, right, is actually what drives insulin resistance, right? But also the microbiome. Microbiome is also important, right? So, all right. Wow, that's a lot. Okay. Yeah. Boy, let me go. This one is still a review. Okay. All right. Okay. Here's glucose plus your oxygen, right, inside your cell, right, to become water and carbon dioxide. You exhale carbon dioxide, but you need energy, right, to make energy inside your cell, right? This is inside your cell, right? The problem is some of this oxygen leaks and becomes reactive oxygen species. It actually loses electrons. It loses electrons, it becomes unstable, right? When it becomes unstable, I put it like a fire there. It's unstable. It's a reactive oxygen species. It's lacking an oxygen electron, right? And it becomes free radicals. This is a free radical. It's pro-oxidative. Now it says, I want to go back to the stable state right there, but I need electrons. So it starts looking for electrons in your lipids, your proteins, your DNA, right? And then now these lipids, it steals electrons from your lipids, your proteins, and DNA, and it causes what? Denatures. Your lipids and proteins and DNA becomes damaged because of the free radicals, right? Right. And this is what we call oxidative stress. And this is what we call inflammation, right? And this is inflammation leads to death, right? Right. So how do you fight this? Right? It leads to death, right? So death is too much oxidative stress and inflammation in these dead cells, right? So you need antioxidants to fight off the oxidative stress, right? Because that antioxidants will actually give up its electron to these lipids and the proteins and the DNA, right? It's kind of like a fire extinguisher. It's like a fire extinguisher right there, right? Right. And where do you get your antioxidants? Your antioxidants comes from your plants, right? So what if you drink a lot of processed sugar? You drink a lot of processed sugar, right? And then you don't exercise. You're just on your cell phone all day, not exercising, and you drink a lot of processed sugar. So a lot of processed sugar, and you're not burning energy, right? The equation, well, you eat a lot of this is coming in, but it doesn't go up that way. So where does it go? It goes down this way, right? You eat a lot of processed sugar and you don't burn up energy, you make a lot of antioxidants, right? This is actually quite, when you look at this, oh, that's simple, That's why eating a lot of processed sugar and not exercising leads to inflammation. And so, obesity is a problem of inflammation as well, right? Right? It's actually inflammatory, right? Now, when you think about this, you look at this, right? These dead cells have a lot of inflammation, have a lot of oxidative stress, and that's why it's dead. Why are we eating dead cells? Right? We're just increasing inflammation in our body, right? Yeah. Okay. All right. This is the thing that I've been studying for the last 2 weeks here. All right. This is the bacteria of your microbiome. This is what it looks like. Now, they have a little, this is the cell wall, and they have these things coming out of it, right? And this is called lipo. You can actually see that here, right? See that there, right? This is actually lipopolysaccharide. Lipopolysaccharide is actually endotoxin. Do you know what endotoxin is? Endotoxin, when it gets into your bloodstream, cause you to go into shock. So why do people, when they have an infection, blood pressure goes down, heart rate goes up, they can't breathe, the heart rate goes really fast, they go into shock? Why? Because of an infection, because lipopolysaccharide. The severe sepsis, the severe shock because of an infection is because lipopolysaccharide. There's too much lipopolysaccharide in you. But if there's only a little bit, it just causes an inflammation, right? The bacteria in your gut, it can be bad, obviously. It can be good, but it can be bad. But this lipopolysaccharide is what gets into your bloodstream and causes inflammation. Now, inflammation is needed, actually, right? Right. But inflammation can cause you to be sick, obviously. If too much inflammation causes you to go into shock and you die, right? But chronic inflammation causes all kinds of diseases, right? Chronic inflammation, right? So here we go. This is your intestinal lining, right? This is the mucus layer, and there's some germs here. There's some germs right there, right? And then here's the cells. The cells here have to be healthy. It has to have these tight junctions. And there's a tight junction here, right? And it basically closes the leakage that could potentially come in through here, right? So if the tight junction is tight in a lipopolysaccharide, right? Remember from the germs, it actually, it does not leak, right? But the problem is that if you have a leaky gut, right? Lipopolysaccharide doesn't get taken through the cell. It has to leak around the cell, right? Now, the tight junction is not tight anymore because of what? Because you don't eat enough food to feed the immunity cells in your intestines. And your cells start having leaky junctions instead of tight junctions. Now the lipopolysaccharide gets in, right? And it's taken up by the macrophages. Lipopolysaccharides are, okay. The body says, okay, we got to fight this lipopolysaccharide, right? We got to fight it, right? And how do we fight it? Now your immunity cells comes in. Macrophages produces IL-1B. Wow. IL-1B. T cells produces TNF, tumor necrosis factors. And this is to fight. This is fighting the cell, right? To fight this lipopolysaccharide from coming in, right? Because when it goes in, now the body is fighting this, right? IL-1B and TNF. Okay, wow, that's a lot, all right? But what does this all mean for diabetes, right? What does this all mean for diabetes? IL-1B goes into your pancreas and causes your pancreas now to start to fail. Your pancreas now starts dying and it stops making insulin. You make less and less insulin. The inflammation in your gut actually travels to your pancreas and your pancreas starts making less insulin, right? So you get less. Even your diabetic type 2, eventually if you lose enough pancreas, you won't make as much insulin, right? And it's from inflammation. That comes from the gut, right? And then the gut inflammation also causes, right, the insulin receptor, right? The insulin receptor now gets blocked by TNF, right? So here's the word here. Remember this? Diabetes mellitus type 2, right? We have, all right, now we have the oxidative stress from the reactive oxygen species, right? It causes hydrogen peroxide to block this mechanism, right? This mechanism is blocked so that the door will not open, right? Because of the reactive oxygen species, because of the free radicals, right? Now we have saturated fat. This is saturated fat here, blocks all of this. Huh? Your door will not open, saturated fat. And remember, the protein 3-HIB is the one that causes saturated fat to come in, right? Now the inflammation in your gut from your leaky gut because not having enough fiber causes TNF. TNF blocks this, right? And interleukin 1B blocks your, causes your pancreas to dysfunction. Now you're not making enough insulin. Your insulin level goes down. Yeah? When the insulin that you have can't open the door, your glucose remains high. And then eventually your pancreas fails and you don't have enough insulin. Wow. This is what, compared to what we studied before, we have much more information now. A lot more information of what diabetes is, So what's the upshot of all this? What should you eat? The kind of food that you eat has to be low in saturated fat, high in fiber, low in animal protein, and low in calories, right? Remember, if you were to go back, when was insulin first invented? 1920s. 1920. What happened before 1920 when a person comes in with a diabetic coma or can't, with blood sugar of 300 to 500 in the hospital? How did they treat them? Before 1920. They gave him oatmeal. Oatmeal is the treatment for diabetes before the advent of insulin. Oatmeal, right? This is pretty amazing. It's called Haferkrutt because in maybe German, but I know Dutch because Indonesia used to be Dutch. Oatmeal is called Hafermout, right? And what oatmeal is, the treatment for diabetes with oatmeal is called Haferkrutt. So they give you oatmeal, right? And look at this, all right? Okay. They gave, this person comes in with very high blood sugar. In those days, they checked your urine. Your urine has a lot of sugar in it. So they gave you your regular diet, usual diet of high fat, low carb diet. What happens? The sugar does not go down, right? They gave it for 7 days. Sugar remains high in the urine, right? Sugar remains high in the urine, right? Remains high. High fat diet, sugar remains high. But as soon as they start giving oatmeal, from day 11 to day 21, right? 10 days. 10 days of oatmeal. Your sugar starts, right? Amount of sugar, right? It starts going down here the amount of sugar starts going down, right? Starts going down. And even afterwards, right? Now they can eat, they can eat meat, some meat, and celery, lettuce, and cabbage. Even afterwards, as long as they continue eating that oatmeal, the amount of sugar in your urine remains down, right? Even afterwards. Right? Sugar, wow. Have you ever been taught this? This was in the yeah. You know why we don't use this anymore? Nobody makes money from giving you oatmeal.
I've always said that.
They make money from giving you metformin and insulin. Nobody makes money from giving you oatmeal. This was the treatment for diabetes. Can you look at that? With a high fat diet, the usual diet, the low carb diet, your sugar remains high in your urine. But as soon as you go on oatmeal, now oatmeal is not processed sugar. This is the biggest difference here. Here with carbohydrates is good for you as long as it's unprocessed. You need unprocessed carbohydrates to actually reverse diabetes. But if you take processed sugar, that's bad for you, right? It makes your sugar go even higher. What you need is the unprocessed fiber, right, in oatmeal, right? Okay, so now they have people with diabetes with taking insulin. And in 1935 now, this is 15 years after the advent of insulin, right? Now they got like, they take people, they go, wait a minute, let's give them a high carbohydrate like oatmeal and lentils and all that kind of stuff, right? And they found out that they could reverse diabetes. Insulin can be discontinued entirely. How? How, you know, yeah, they can actually stop people from having to take insulin, all right? Carbohydrates improve, fats impair insulin resistance. 1935, they already knew this, right? So these are 20 people, right? 20 people on a high-fat diet, right? And then they changed it to a high-carb diet, right? This is a high-fat diet. They changed it to the high-carb diet, all right? Low-fat diet. And these people, right, this is high-fat, low-carb. High-carb, low-fat, right? Right? These people were average, some of them had to have been on insulin for 20 years. The average of these 20 people have been on insulin for 8 years, right? Anyway, these people have been insulin for 8 years on an average, right? And then they gave them a high-carb, low-fat diet for average of 16 days, right? 16 days, right? 16 days. Look at what happens. If they were on a high-fat diet, their requirement for insulin remains the same, right? As soon as they put them on a high carbohydrate, now the carbohydrate has to be unprocessed carbohydrate, like oatmeal. You can't be eating candy and you think you're going to bring it down, you know. You got to be the unprocessed fiber, right? And within 16 days, the requirement for insulin went down to 0. They reversed diabetes in 16 days. Can you imagine that? 1935. Right? 50% of these people got off insulin. Now, not all of them got off insulin, right? Some of their pancreas already shot. The pancreas is already shot, right? Some of them. But those whose pancreas is not shot yet, you know, they can actually, 50% of them got off insulin. And the majority, the average, they used to be on 26. Average 26 insulin, units of insulin a day. They went down to 11. So they were, on an average, they all went down. But 50% of them got off insulin, right? Pretty amazing, right? Now, why is that? Because it's low calorie. Why is oatmeal so good? It's low calorie, it's high fiber, low saturated fat, no saturated fat, and no animal protein. This is why it works, right? Yeah. And you know, obviously, the microbiome plays a big deal in this, all right? Yeah. And what happens also? Even after they stopped, let's say they go on this they go on this diet, even after they stopped, right? For 4 weeks, even after stopping this for 4 weeks, they still had an effect, right? Their hemoglobin A1C remains low. Why? Why does the effect last for 4 weeks? Because their microbiome changed, right? Right? So when the microbiome changed, you know, that effect lasts for a while, right? Right? It's not just the oatmeal for that time. So it affects the microbiome. That's why it lasts for a long time. Right? Okay. Right? Well, you know, I have to close with some Spirit of Prophecy quotes. Right? Yeah. The moral, appetite and passion are the ruling sins of the age. Appetite, the way it is indulged, influences the stomach and excites the animal propensity. The moral powers are depressed and become the slave to appetite. The use of flesh meat stimulates and inflames. This is a third grader who never went to high school. And she writes like this, it stimulates and inflames. Inflammation. It's talking about inflammation, right? And produces diseases of almost every type. The inflammation is the underlying cause for so many diseases, right? Yeah. This state of inflammation, is the basis of a lot of the diseases, right? Imagine, she wrote this in 1868. Right? Now this one here, huh? She's talking about, how dangerous it is to eat sugar, which is like in the cakes, sweets, puddings, pastries, jams. This is processed sugar plus milk should be avoided. Now, why does processed sugar and milk have to be avoided? Because processed sugar obviously has processed carbs, and milk has the saturated fat and the protein, right? And with the valine, right? This is, she knew she, we just basically just proven, right? Scientifically. Milk and sugar should not be taken together. It should be avoided as much as possible. What does this mean here? Is ice cream good for you?
Oh yeah, most Filipinos dessert.
Yeah.
Most Filipino desserts.
Yeah.
So good.
That's why it's so good. Because it's bad for you. I tell you. All right. So hopefully this has been informative. I had, it was it's a lot of information here, but I think if we actually put that all together, we know a lot more about diabetes now. Yeah. And not only is for us, right? We want to prevent diabetes, but we can actually claim that diabetes can be reversed. And it actually, if it's not to the point where your pancreas is already gone by interleukin 1b, right? If your pancreas is still functioning, you can reverse diabetes in 16 days. Can you imagine that? Yeah. With all this knowledge, yeah, it's a lot. Yeah, that's good. Yeah, the doctor gave you metformin, and you gave your metformin to somebody else, right? Yeah, they want to give it.
Was just 5.
Yeah. Yeah, your pancreas is still good. Now, obviously, if your pancreas is damaged, it's tough, right? That's it. Yeah. But if your pancreas still good, you can actually reverse diabetes. A lot of people when they go to the doctor and they say, well, you used to be on metformin, now you have to take Ozempic, now you have to take insulin. It's a progressing thing, Every few years, I have to add this. Now I have to add this. Now I am on insulin. It's like they give up, oh, wow, I'm stuck, right? Unfortunately, if only they studied history. Man, this is like in the 1920s.
I can see it every day. Right? Remember, it went down drastically since she's been whatever.
They test my inflammation and I have some inflammation. Inflammatory markers. So, we're chilling all the things going on inside.
This is just amazing. And you know what? we use scientific knowledge to actually prove biblical truth, right? Bible truth is, it's there. It's already there. But if we can actually use the scientific knowledge that we actually get, and we prove that the biblical truth that we actually hold on by faith, right? That actually makes us much more educated, right? And be able to continue and sustain the type of the type of lifestyle that we need so that we can be healthy. Amen. All right. Okay.